Welcome, everyone. My name is Mohammed Qasim, the co-founder and CTO of eFabless. I welcome you to the today's webinar as a part of our series around generative AI. And today's our guest speaker is Dr. Erik Berg from Microsoft. Erik is a principal SOC verification expert at Microsoft. And he has been leading the charge in creating scalable methodologies for design verification and making it more robust, less risky. And that includes some of the work that he's been driving internally within Microsoft about how do you apply generative AI and using generative AI in the same direction, where it improves the robustness and the productivity of design verification, where you can apply generative AI as a one of the propellant engines or the tools that accelerate and also add more arms and hands to the current methodologies that we usually use through just the regular automation. And now he has notable contributions to the field. Some of one of the tools you may know, it's called debug decision tree tool. That's it's about enabling better debug and knowledge sharing in a collaborative way across teams. And he holds a PhD in nanofabrication from University of Michigan. Welcome, Erik. And here you go. I'll give you the presentation. And just actually before I do that, we're going to have the presentation, and then quite a bit of time, good time we're going to leave for Q&A. Please use the Q&A button on the Zoom session and be able to, so that we can actually have a record of it, and we can exchange and maybe publish it later. And then we're going to read the questions for those who just write the questions, so we can read it for everybody else so that you can hear it. And then, as you know, as you probably see around the presentation or the Zoom session, that the presentation is recorded. So, Erik.
Thank you, Mohammed. I'll get my share set up here. So thanks everybody for joining. I met Mohammed this year at the DAC conference in July, I think it was, and we got a chance to have pretty substantive conversation after our respective tech talks. I've been working on leveraging generative AI since December of last year, when it first kind of burst onto the scene. And I've been very interested in automation for all verification activities for many years. And as soon as it was available, generative AI and ChatGPT specifically seemed to be the final arrow in my quiver of tools that I needed to be able to really have autonomous verification systems. And so I'll share with you some best practices, directions where we're going. In the presentation, I try and keep it relatively short. I don't want to fill most of the time with me talking. I want to get to the Q&A as quickly as I can, but I need to set the scale and set the agenda so that we can have a better conversation. So here we go. So this was when I first went to my management. So I started playing around with ChatGPT around Christmas time and was very shocked and impressed by what it could do. The initial results, I would say, were interesting but not useful, but you could see enough of what was possible to know that this was going to be a massive inflection point for how we do our work. After playing with it for a while, I put together, this is my initial slide in every talk, because this is what we want. We want, once design gets done writing individual modules, we want to be able to use generative AI to put formal benches around each module. This is something obviously that we can't do manually just because there's too many of them, but it is kind of the preferred state for verification, because this allows us to find bugs at the smallest possible in the smallest possible design. And ideally, we would find these before the code even gets committed to the project repository. So the expectation would then be that design could go ahead and leverage these tools to create logically clean modules before they commit them to the repository. Once those modules are clean and committed, there's going to be the subsystems are going to get built up, and design can go ahead and make those connections. At some point, the state space gets to be too large, and so we won't be able to use formal tools around the subsystem to be able to get the results that we want. At that point, we'll start turning towards UVM test benches that are generated, again, using ChatGPT or whatever generative AI solution that you want. And those benches, of course, they're going to be more, they're going to look at the subsystem at a higher level of verification, because they know that the lower submodules have been fully verified with formal. So it's going to change the nature of the UVM benches that get built, because you're not going to be necessarily looking for the bugs in the small modules. You're going to be looking for in the interactions. And of course, when we're generating our stimulus and analyzing our coverage, we can collect all of this data off, and this should be a kind of a closed loop, right? I don't see why people need to be tuning random tests. The machines can do it with much greater fidelity and much greater accuracy based on the nuances in the coverage data and the relationship to the input stimulus. So this is kind of the holy grail for verification. I meet with EDA companies, and if there are any on the line, if you're not aspiring towards this kind of module, I would say that you're not using your imagination enough. I meet with teams who don't seem to understand the full capabilities of what's available with generative AI. But this is where we want to get to, and this is how verification is going to be going forward. And I will say there are components of this that I've built myself. So this isn't just kind of vaporware and aspirational thinking. This is real. I'm filing bugs with it, and it's definitely something that you can lean into for your designs. So when I'm coaching teams at Microsoft, I always get this question: how do I start? What do I do to begin using ChatGPT? How do I write my questions? And the simplest answer that I give to teams is you treat it like you would treat a person, right? If you're not sure exactly how to get started on a problem, tell it about your problem. Tell it what you want to understand. It may come back to you with more questions. It may ask you to clarify when you say, I want to build a UVM bench for this module or for this subsystem. It may ask you questions about the nature of the traffic that you want to have in your stimulus. It may ask you about the different agents that you're going to require in your test bench in order to get the level of accuracy that you want. But when it's, somebody asked me one time, they said there's no help menu. And of course, the answer is that ChatGPT is its own help menu. Don't be afraid to ask it questions. Don't be afraid to push back and say, I don't understand what you're talking about. Can you clarify this point? So, how do I start? If you want to build a test bench, if you want to build a new tool, if you're not sure how to start, ask it. Tell it what you want to do with as many details as you can, and see where it guides you. But inevitably, if you want to have success with ChatGPT or generative AI, this is where I see teams when they're not getting the results that they want. I just talked to them about deconstructing the problem, right? It's not a surprise that you can't say to ChatGPT, verify my SOC. Nobody would expect that to be something that it can do. But if you asked it to write a 2-bit adder, it's not shocking that it can do that. So you have to go through, and when you're asking ChatGPT or again, any generative AI tool for specific results, if it's not meeting your needs, go back and look at what you're asking for and see if it can be broken down into smaller components. The example that I'll give is when I built my formal verification copilot, I was asking for modules to be bound into my RTL, or I was asking for a formal test bench that had the following properties, and I wasn't getting the results that I wanted. But if I said, I want you to build these properties, and then I took the properties that were built and I asked them to build a module, and then I asked it to take that module and bind it to a specific chunk of RTL, I have very good results, right? So if you're not getting what you want, take a step back, see if there are, smaller, more easily constructed components to the problem, and then ask ChatGPT to go ahead and synthesize all those components at the end. And this is kind of the secret, right? So if you're not getting what you want, take a step back, break it down. I think part of what has enabled me to make fast progress on this, and why a lot of the interaction with generative AI has been fairly intuitive, is there was the tool that Mohammed alluded to, the DDT tool. It's a tool that I co-developed with Synopsys. It was based on an open source package that I wrote called Then What Tree. And a lot of people in verification, they tend to, they'll own an IP or they'll own a subsystem for large portions of their career, and they become very familiar with an architecture. They become very familiar with how designs are done. That's never been my experience. I've been bouncing around from IP to different SOC flows and back, every 6 to 8 months throughout my career. And so I've had to debug across a lot of different environments. And what became clear to me was that debug, regardless of the platform, regardless of the IP, regardless of the flow, they can all be represented as decision trees. And a lot of times the decisions in the decision tree are platform agnostic. The only thing that separates debugging PCIe at the IP level and simulation from PCIe and silicon is just the data that's available to you. But I got very good at debugging and representing the flows in these very granular decisions. And it's a good analogy for what we want to do with generative AI. If you're unable to get the results that you want for a specific problem, take a step back and think about your own workflows. If you had to teach this to an intern, what are the steps that you would have to teach it along the way? And then go ahead and organize your workflow that way as you're presenting it to ChatGPT. Again, the best way to have success with ChatGPT or any other generative AI is to treat it much like you would if you were working with an intern, if you're working with a new person, if you were trying to roll off a project and you had to enable somebody else. ChatGPT, it's not magic. It relies on the contexts. It relies on the directions you're able to give it. And the more explicit you are, the better the results that you'll get. So what you'll find is that once you've got your problems represented at the appropriate level of granularity for ChatGPT, prompt engineering is going to get you across the finish line. There is a paper here that I put a link to from Professor Jules White at Vanderbilt University that goes through and describes probably about 20 different types of prompts that can be used to interact with ChatGPT. He gives very good examples so that you can, apply this to your specific context. But so all of the work that I've done, we've done no fine tuning. We're working off of the same model that's available publicly through ChatGPT. But when you go through and you start breaking down your problem into its component parts, you can do very specific prompt engineering for each one of those parts, right? So again, back to the example of a formal verification copilot, there will be different prompt engineering that I do when I'm building properties compared to the prompt engineering that I'm doing for building modules, compared to the prompt engineering that I'm going to be doing for creating bind modules. I think one of the mistakes that people make is that they try and give too generic of a context when they're doing their own version of prompt engineering, and it's just not quite specific enough for ChatGPT to understand the nuance of what you're trying to do. So break the problem into component parts, go ahead and think about, collect your syntax examples that you've got for each of the different components, and then go ahead and build your prompts. And all of the stuff that I do is, it's 5% generative AI and about 95% scripting. And that is building up the prompts for the specific components of the work that needs to get done, and then running them through the API and then collecting the results. When you're doing the prompt engineering, there's going to be basically 3 components. There's going to be some sort of instructions you're going to give to generative AI about what you're looking for. you're going to give it an example from, you're going to describe the specific context that it's working in, and then you'll probably end up giving it a number of syntax examples so that it understands, in the areas where it's not successful, what it should look like. And I skipped this in the beginning, but don't start immediately with the prompt engineering. Ask it for what you want and see where it is unsuccessful, and then go back and kind of beef up your prompts in those scenarios, right? You will find surprising goodness from ChatGPT in areas where you don't expect it. And there may be, areas where you're expecting it to do well, and it's not. But don't start off with the prompt engineering. Just try and, you will have to, break your problem into the component parts and do the queries for each of them. And then in the areas where you're not getting success, look at where it's falling down. Is it not identifying clocks correctly? Is it not choosing the appropriate signals? Is it not, setting up the syntax for what your formal properties are supposed to be like? And then go back and give it examples around the areas where it's not being successful. So, the beyond the specifics of verification, I use ChatGPT for almost all components of my workday. And this is just some stuff I've scraped from various ergonomic sites, but we peak before noon, and you can really only focus on complex tasks for about 4 hours a day. The menial repetitive tasks drain the ability to work on the complex tasks, and again, everybody's got meeting schedules that impact your focus time, right? So what I'm able to do is I'm able to come up with the different flavors of prompts that I'm gonna want. I can spin up new versions of formal benches in those half-hour openings that I've got during a day, because I've spent enough time building up the tool so that now, instead of having to reserve 4 hours to go and write full benches, I can spin them up pretty quickly. And this is kind of this has been the biggest win for me as somebody who has more ideas than time in the day. It's really allowed me to accelerate the implementation of my ideas as prototypes. And it turns out that the prototypes that I'm spinning up, some of them don't work, and that's fine, because it didn't take me very long to spin them up, and I'm very happy to throw them away. I don't have that emotional attachment to code because I've been working on it for a few weeks, right? I can code faster, I code higher quality in much smaller time windows. It allows me to take advantage of new packages and language features. There was a library that I had written for the DDT tool, and I'd spent a lot of time getting it right. And I'd spent a lot of time analyzing the performance of the different functions because I was working on some relatively large data sets. I had unit tests in place to protect all the functionality. And I took the entire library and I gave it to ChatGPT and I said, can you rewrite this for performance? And the prompt was a little more explicit, but it came back in the the functions that it returned for me. The refactored functions were anywhere from 2 to 5 times better from a performance perspective than what I had written. And they all passed the unit tests that I had created for it. So I had no degradation of functionality and 2 to 5 times improvement in performance, right? And it did this because it took advantage of packages that I didn't know existed. It took advantage of language features in Python that for whatever reason I was unfamiliar with. And so we get, the breadth of knowledge that's available from across the internet to be able to improve our own work. And it frees us from syntax limits. I think this is one of the ultimate goals with the co-pilots that I'm building, is it allows people on my team to go ahead and write English language versions of what it is that they're trying to generate. Maybe it's a section in their specification document where they've collected the assertions that they want, and they can drop those into the formal verification tool, and they can generate the properties, generate the modules, generate the binds. And it frees them from having to know the nuances of the syntax, because we've collected those nuances from experts. We've added them into our prompts, the prompt engineering scripts that we've got, and given everybody access to that. I don't do debug anymore for the most part. I just usually take the stack traces and I give it to ChatGPT. Occasionally it needs a little bit more context, but I can just paste it in there and say, help me understand, here's my function, here's the exception, what's going wrong here. And again, it's back towards preserving those 4 hours of productive time that I've got in a day, so I don't burn it on things that aren't adding a ton of value. Now, I'm not going to tell you that ChatGPT is going to give you everything perfect all the time, but we can get to a level of accuracy in the code and the properties that we're generating, above probably 95%, if I was going to give you a number. And what that allows us for is, one of my coworkers has described it as she now views every single keystroke as a waste of her time. So, 95% accuracy on generating hundreds, if not thousands of lines of code is pretty good. And as long as we've got the code done in the appropriate, level of granularity, it's pretty easy to debug or find the places where the gaps are. There was a paper from Harvard Business School that came out a few weeks ago, talked about navigating the jagged, they called it the jagged edge of AI. There are tasks that even if you sufficiently deconstruct your problem and you do all the prompt engineering in the world, you will find tasks where it just does not work. And nobody knows where those boundaries are right now. We're all trying to figure it out. There's not a lot of rhyme or reason to some of this. So I mention this because two things. In the paper, they talked about how for the difference in the level of productivity. So they had three groups of people that they had separated out in the paper. One were people who were just doing their work. One was a group that was using AI, and one that was using AI with some additional training. And for people that had AI with some additional training, their productivity went up by over 40%, which is 2 extra days of work per week that we're getting for free by leveraging some of these tools. One of the other interesting notes in there is that if you take somebody who's in the bottom half of their peer group and you give them training along with access to AI, they became more productive than somebody who was considered an expert who was not using AI. So like I tell folks on my team, AI is not going to take your job, but somebody else who is using AI will be more productive than you if you're not. So it's time to get on board. And everybody has heard about the hallucinations, and so I hear about this a lot. What about hallucinations? There will be code that you get back from ChatGPT that is flat wrong. It is, at the end of the day, even with prompt engineering, even with breaking things into the small granular problems, it is a stochastic process. There are times where it is just flat wrong. And what do we do about that? One of the techniques that we've used is that I use AI to check AI. So if I ask for a set of properties, and again, using the formal verification analogy, if I ask for a set of properties, I will take those properties and I will feed them back to AI inside the script and give it a set of requirements to check against. And if the code that is generated has not met those requirements, I ask it to regenerate it again. So, the Venn diagram of ChatGPT hallucinating in the exact same spot 2 times in a row is pretty small. And so we will, when we're fully automating some of these benches, that's what we do. Ask ChatGPT to check its own work. And sometimes, let's say something sneaks through that's still not working. At the end of the day, we're writing software, even if it's in System Verilog and we're doing it for hardware, it's got to compile. So if there are hallucinations and it's preventing compilation, you'll find those bugs and you'll go fix it. There's going to be other redundancies that we've got, whether it's looking at coverage output or any of the other feedback tools that we use. And so there are safeguards that typically apply to our processes. But again, if we think about generative AI as if we were hiring a whole bunch of interns, we wouldn't expect them to have perfect output either. And so how would you check your interns' output? Whether it's manual review, whether there's other code quality checkers that you would use. It's not going to be perfect, but neither is the code that the people are writing. And we've figured out ways to manage that. So where are we going with this? I'm pretty sure that we are going to be moving away from giant LLMs that are general purpose to much more domain-specific LLMs as we start to get better understandings of how exactly we're going to incorporate these tools into our flows. I put a little screenshot here of just the front end for the formal verification copilot that I started playing with as a prototype. And you can see there's a button for create properties. There's a button for generate property module, generate bind modules. Let's go ahead and edit the configurations that we want to use for this particular RTL block. Let's go ahead and update our compile to make sure that we've got the files in there that we need. Let's go ahead and build our tickle script so we can run our formal tools, right? And then let's generate a Word document. These are all separate things that have different modules under the hood that are interacting with generative AI in different ways. I will say too that this in the past I've been very comfortable writing backend flows and managing data and algorithmic programming. I've never been good at creating front ends. It's just not an area that I'm super interested in. I find the syntax to be somewhat tedious, and it's difficult to do unit testing to make sure I've got all the bugs out. And so typically the tools I've written in the past have been all command line driven. But that introduces a separate set of problems for getting people to buy into data structures and having common understandings of how the tool is going to go. I was sitting there and I was trying to figure out, I didn't like the current front end that the current command line front end that I had for the original tool. And it kind of occurred to me that what if ChatGPT wrote the front end? So I started from scratch and I asked ChatGPT, how would I write a front end tool to interact with these algorithms that I have? And it kind of guided me through the process, right? And so in the span of a little over 3 days, it was probably about 4 days of focused work. It ended up being about a 2,500 lines of code in my GUI that has allowed me to deploy this to other teams so that we don't have to talk about command line switches. It's much more intuitive because they've got the GUI interface. And I was able to do this even though I am not a front-end coder. I had not used the package before, and all I had to do was talk to ChatGPT explicitly about what I wanted. There was a podcast, if you have a chance to look it up, from a guy named Lex Friedman, where he was interviewing a gentleman named Alex Wolfram, who is kind of an AI legend. And one of the things that Alex Wolfram mentioned was that there's this fear that all the writers in the world are going to get laid off because ChatGPT can do all of the writing for you. But the irony is that if you really want to get good results from generative AI, you have to become a very good writer. And I found that when I was building up the front end for this tool, you have to get very explicit about what you want the look and feel to be, where you want buttons placed, what specific functionality you want buttons to do, how you want the buttons to interact with each other. And it requires a very explicit form of expository writing in order to be able to describe what you want, because it will fill in the gaps for the areas where you don't give it explicit instructions. It will go out and do things on its own, and it may not be exactly what you want. So you might have to regenerate as you start to see where it is, where the holes in your instructions are. So how's this changing how we work? There's another link in here. There's a website, Microsoft Work Lab. They've got a lot of good information about the approaches to using AI. And again, if you treat AI as the world's greatest intern, or as I tell people here, all of a sudden you have access to 10,000 interns, how are you going to use them? It's going to require you to give explicit instructions. It's going to require you to check some work. But at the end of the day, it should free you from a lot of the tedium that we have as we're doing our own implementations. It's going to require us to restructure problems into component parts. We talked about that. It's actually harder than you would think. There's a lot of us who are very good at verification, and we've gotten good at it. We've gotten efficient at it, and there's a lot of muscle memory built in. When I interview experts in various fields, as I'm trying to build up copilots to replicate the work they're doing manually, it takes a lot of whiteboarding and really poking at the nuance and the detail of the work that they're doing to be able to get them to actually recognize everything that they're doing in their workflows. So restructuring the problems in the component parts and getting that expert knowledge captured into, when I was doing debug, I had it in a decision tree. Here it's more of a workflow diagram. It requires a little bit of work to be able to get people to start thinking in that way. And of course, we need to restructure how we write and represent specifications. We want to be able to get the specifications explicit enough so that we don't have to have all these back and forths and interpretations with architects about what they implied by writing things in a specific way. And that's not to say that we need to develop a new type of syntax, but it is to say that we need to make sure that the specifications are as explicit as they need to be for us to be able to leverage ChatGPT to get the results that we want. So in conclusion, the things I want you to take away from this are that, deconstruct your problems, be aggressive in your prompt engineering. I didn't mention it before, but small prompts are better. And that kind of goes to the theme of deconstructing problems and being aggressive in your prompt engineering. Small prompts are better. Asking for less will get you better results. And then ChatGPT is, again, very, very capable of synthesizing its own results and stitching them back together in a way that will give you the larger solution that you need for your verification collateral. And this allows us to tackle more interesting, challenging, and complex work. It frees us up to be able to go off and explore more of the prototypes that we want to be able to develop. Some of the prototypes in the past that I've wanted to build would have required me to beg, borrow, and steal time from other people's sprints to be able to get access to the expertise that they had. And all of a sudden, I've got access to the entire internet to be able to build up these prototypes. Adoption is going to require deconstruction of workflows. I keep hammering on that, but that really is the kind of critical nugget to be able to get the results that you want. And the future of hardware design verification, this is already being transformed. We're doing it internally. I'm seeing presentations from EDA vendors where they're trying to do the same things. And this is it's gonna allow us to kind of up level our skill set, free us from some of the more mundane aspects of our work, and be able to get through our projects more quickly. And with that, Mohammed, I'll open it up for Q&A.
Thank you very much, Erik. Actually, on the Q&A, we have many questions. We have about 17 questions now. And so what we'll do is that I'll read the questions out loud just to make sure that everybody sees it. And if anyone does have a question, that put it in the chat. If you could please put it out back in the Q&A so we can have a record and everybody else can see it, especially when the answer is being typed. So, okay, thanks, Erik. So I'm gonna just start. The first question is from Emmanuel Dre, and I apologize if some of the names may not get right, but how do you foresee the AI-assisted analog and layout design? What would the next advances we could expect in this field?
So it's funny. I've actually spent a fair amount of time working with analog teams, and as we go through, again, as we deconstruct some of their workflows, a lot of what they're asking for hasn't really required AI. They think some of the problems do, but part of the challenge here is to actually use the right tool for the right problem. And I'm not a layout guy, but from the work that I've done with the analog circuits guys, I can see that it's kind of the same process. It's if you want to add capacitors into a circuit, you just have to start talking to ChatGPT about what you want the end result to be, what you want your approach to be, and let it guide you through the process. It may end up asking you questions back as well. One of the things that you'll see in the prompt engineering is that you can give personalities to ChatGPT, and you could tell it, hey, you're an analog circuit designer, and this is the challenge that we are facing. How would you approach this problem? What are the steps that we're going to need to go through in order to reach the end? And can you help me build a solution for each one of those steps? So regardless, again, whether it's front end or back end stuff, it's kind of the same process. And I can't quite speak to the layout because I haven't done as much of that. But the analog is certainly a very tractable problem.
Great, thank you. And next question is from Daniel. Are you interfacing with ChatGPT through the chat interface or through the API access to the model? If through the API, what applications are you using?
What application? Mine is just a straight Python API into the model. I mean, it kind of depends. If there's like little one-offs that if I have a question about a specific chunk of syntax, I might throw that into the chat. But all of the tools that I'm building are specifically going through the Python API into the OpenAI model.
Okay. Next question is from Anonymous. Can ChatGPT be used to generate a full UVM test bench environment for a specific device under test?
Yes. I mean, it's if that's the level of prompting that you're going to give it, create a UVM for this design under test, you should expect that level of quality in the result, right? But I would take the device under test, and I would provide it to ChatGPT, and I would ask it questions about how it would approach the problem for building a UVM bench, and then see the process and follow the process that it kind of advises. But I mean, I have not found an area of verification where I have not been able to use ChatGPT to get leverageable output.
Got it.
And Mohammed, I want to the previous question about the Python API again. With the tools that I'm building, it feels like 95% of the work is in using scripts to set up the contexts, to build the queries that we're sending off for the specific task that's at hand. And most of the work is not in generative AI. Most of the work is in the scripting.
Got it. Thank you. So next question from Saad Sadiqi. Trying to write an Verilog code for I2C protocol using ChatGPT, broke it into different modules and asked it to give the code. The codes are very optimized, but the finite state machine is not up to the mark. GPT isn't able to generate a better FSM. So any suggestions?
So I would ask if you have other examples. So when you say it's not up to the mark, I guess it kind of depends on how it's not up to the mark.
Yep.
If there's a specific, get more aggressive into prompt engineering in the areas where you see it's not up to the mark. I mean, there's clearly a gap in what it's been able to learn from the internet. And so you may have to provide it some additional context from your own code about what you would expect to be returned for various scenarios. What I found in prompt engineering is that when I first started writing context or syntax examples that I was sharing as a part of the prompts, again, I had a very kind of deterministic approach where if I wanted to, I felt like I needed to provide individual examples of syntax with only one parameter changed on each instance, because that's the way that we do engineering, right? You change one thing and you look at the difference, and then you to determine if it's related or not. Prompt engineering is with giving syntax examples. It got to be very tedious, and we found that we were actually putting more effort into that than we were getting back in terms of value. And so we stepped back and we said, what if we got really sloppy in the syntax examples that we were providing? And so instead of giving examples where we were tweaking one parameter at a time so that it could understand the difference between different questions to see the results in different prompts, we started changing 4 and 5 parameters, or just giving it wildly different examples of different queries and not necessarily connecting the dots. And somehow it does it. There's a little bit of black magic that happens. So if your FSM is not giving you the result, if the results from ChatGPT for your FSM are not up to the mark, look at and see where the gaps are, and if you can provide examples in any of those areas to help it understand what you want. And ideally, the prompt engineering that you're doing or the syntax examples that you're giving, even though it might seem like a lot of upfront work, it's probably going to be leverageable in other scenarios. So when I was working on one particular IP and I had to build up a whole bunch of syntax examples to be able to get coverage done correctly. It seemed like a lot of work, but then I moved to another IP and the exact same syntax examples worked, even though it was from a different IP, right? So it was kind of a one-time cost that I could then leverage across multiple IPs. And so all of a sudden the ROI starts to creep back up again. So look at where it's falling down, provide syntax to help it get over, help it get improve the quality, and then continue to follow that process.
Got it. Thank you. Next question from Shane Dode is, will the presentation material be available after? The answer is yes, and it will be recorded as well, published on YouTube for ePublish channel. Next is that how to retain the creativity and originality of the humans who code better than ChatGPT.
There aren't many people that are better. And it's a little bit, I know it's damaging to our egos as verification engineers. We all think that our test benches are, kind of like Picasso's, but it turns out they're all basically paint by numbers. And I don't think that that's the place where we provide the most value. And I don't think coding test benches is the place where I get the most enjoyment, right? So let's leave that to the machines, and let's move on to higher level, more abstract problems.
Okay, thank you. Jamie, next question from Jamie. So Jamie from Allegro Microsystems, 100% agree with everything you said. We have followed a parallel path since last December. Okay, thanks, Jamie. And then also great for converting into Python. Also great for converting into Python behavioral code. Verilog A models for analog are also very valuable. Code commenting, documentation, assisting, etc. Thanks, Jamie, for your comment and sharing the support for that. Tim, this is a question from Tim Edwards, that will image analysis capabilities in ChatGPT-4 allow ChatGPT or GPT to debug Verilog code by letting the AI analyze actual waveforms? Have you tried this?
So short answer is no. It's been great for code debug. I think for hardware debug, we're not quite there yet. I've got some ideas that we're starting to play with, but short answer is I don't know yet. That's certainly the kind of the next frontier after we get the test bench stuff. But we've left debug to the people for now. At least hardware debug. I'm sure eventually the machines will help us there too. Okay.
I do have a personal, I think it's going to happen. So there's no reason it wouldn't be. As a matter of fact, I think it's also going to get into DRC and others. Okay. Again, from Shane, Shane Dawood, it would be very interesting to see some examples of the scripts that you use to feed ChatGPT.
So I can't show you those, but what I can tell you is just remember it's text in and text out. And if you go back and I'd review the paper in there from that I cited on the prompt engineering slide, and think about the specific scenario that you need a prompt for, whether it's if you want to create an interview bot, if you're trying to do kind of strategy discussions, if you're trying to just write code. Just remember all the interactions with ChatGPT are text in, text out. And so go ahead and use your scripts to build up the right syntax examples and describe the context, and then go ahead and give it your specific problem that you want, and see what pops out.
Great, thank you. So the next question is from Braulio in Martinez. We've seen a difference in performance and accuracy between public ChatGPT and Azure OpenAI ChatGPT. How can we close the gap?
So I should clarify, I'm not using the public ChatGPT. I am using the Azure OpenAI version because we've got, a secure endpoint where we're putting our, our proprietary data into. There may be differences in the quality, but when we're doing our prompt engineering, it's kind of the equalizer. We don't necessarily, we don't really see it, even if there's a difference in quality, it doesn't impact, how do I say this? We get the functionality that we want, and we have not had any issues with using the Azure OpenAI endpoint.
Got it. Thank you.
And I would just add, remember, if you're not getting, if you feel like that if you're using the API and the quality you're getting isn't quite what you wanted, you might put a couple of layers on it where you have it check its own output. That's been a fairly robust way of making sure that, and sometimes it'll spin on its own stuff a couple of times, and that's fine, but it saves you from having to do that intervention.
Thank you. Next question is from Krishan Murthy. What controls are in place to ensure data is not used beyond its original purpose for solutions through generative AI?
I'm not sure exactly what you're getting at. When we're doing it in the Azure OpenAI services endpoint, our data is not, it doesn't leave and go back to OpenAI. It's that feedback loop is not there. So, the data that we're providing to it or the prompts we're providing to it don't go anywhere else. They stay inside our firewall. So it can't really be repurposed.
So can you say this? Actually, I'm gonna just have a follow-up on this. Can you say the same or comment on the OpenAI outside the Azure? Whether you can say the same, meaning that the data, the data obviously goes somewhere, right?
Yeah.
So,
yeah. No. So we don't use that explicitly because of security concerns. We only use the internal Azure OpenAI services on a secure endpoint. Yeah, if I was planning a vacation, maybe I would do that on the public one. But for anything work related, we're only working within the secure environment. So I can't speak to. Yeah.
Thank you. So I think Jamie has, I think there's an answer here actually, but GPT-4 plugin plugins allow diagram and flowchart creation mode. I think this was kind of an answer to, or kind of a comment related to Tim Edwards' question. So thanks, Jamie. Steve Hoover, thank you. Erik, you mentioned ChatGPT. The ChatGPT will sometimes respond with a question to seek clarification. This doesn't match my experience. I have found that it's very difficult to convince ChatGPT to convey uncertainty, or ask clarifying questions. Instead, it hallucinates. Okay. So I sometimes ask specifically what information could clarify a question before asking the question. Do you have some additional tricks to help with this?
So I would say, again, I'm going to point you back to the paper that was that had all the prompts and the design patterns in there. And I've been doing this for a while, and I thought I was really smart for figuring out a lot of these prompts. And then I found out that the paper had been published about 4 months earlier, and I just never seen it. So one of the patterns that's in there is the interviewer pattern. And so if you're you might start your queries by telling it, hey, by the way, you and I are collaborating to solve this problem. We need to make sure that we stay aligned by asking each other clarifying questions to make sure we share a common understanding of where we are in the solution. Given that, here's the context, and this is the problem that we need to solve. And you will probably get a different response than what you've gotten so far. A lot of it is setting up that interviewer pattern and making sure that ChatGPT knows that it's collaborating with you and that it needs to be able to align with you from time to time in the conversation to be able to make sure that you guys understand the problem in the same way and are still working together.
Okay, and actually, just in a minute, I'm gonna just share the in the chat. I'm gonna share the link to that paper, just to make it easy. So I just did. Jaya Ram, the question is, how do you create domain-specific LLMs?
So you'll have to ask me that when we do the next webinar in 6 months. We're in the process, so I'll have better details for you next time we talk.
Great, thank you. The next question from Conlin Han. Do you have any suggestions on for entry-level verification engineer, as GPTs are doing better in DV?
Yeah, so if you're how do I say it? If you're entry level, what I would probably do is so first off, it's very easy to write your own tools using ChatGPT, right? What you might consider doing is, look at areas where your team spends a significant amount of time. Think about the tool that would be useful there, and then try and pull in a senior person who you would typically go to for syntax or strategy or whatever, and then do the workflow interview with them, ask them for specific examples of the code that they've written, and start to pull that into the tool that you're building in order to be able to accelerate the flows. I mean, you can absolutely leverage the insights of experts, completely democratize the process by giving access to it, giving everybody access to the expert knowledge from within your team, and allow, the incentive is, you don't have to go through the same growing pains to learn all that kind of stuff, because there's not a ton of value in it, and allows you to also learn from them as you're incorporating their thoughts into your tools. So it's kind of win-win. It frees them up from the questions that you would normally ask them. It gives you, coded examples that you can explicitly understand, and just allows your team greater access to that knowledge so that everybody can be working more quickly together.
Got it. Thank you. By the way, Erik, if you could, a couple of things. If you could unshare your screen so I can actually share just a slide for links.
Yep.
And I'll keep it just shared while we're talking. So, okay. So the next question is, from Raghavendra A. Do we get different combinations of results when we asked ChatGPT to write a simple adder circuit? And by the way, just before I continue with that, right now we're like 5 minutes before the hour, and we still have 40 questions. So this is great. I just wanted to have a strategy for answering the questions, and I think it depends on whether we can continue this a little bit more beyond the hour, or also answer the questions offline and provide them out there. The one thing that I also would like to encourage you guys, the slide that I'm sharing on the screen has a link for our the Slack channels, and once you sign up through that link, it will take you to the Generative AI challenge channel. So discussions there are also encouraged, and then we can address the questions or maybe post the answers there too. So please join there. So back to the question, do you have any suggestions? Yeah, I said we got that. Okay, and then the next question: do we have different combinations of results? Do we get different combinations of results when we ask ChatGPT to write a simple adder?
I mean, at the end of the day, the only thing that matters is whether it's functionally what you want, right? So if you get different results and they're stylistic, who cares? You may get different things on different days, but if they're all functional and they meet the requirements of what you need, who cares?
Thank you. Next from Tim Edwards, is a 32K context better than spending the time to reduce the larger problem into smaller chunks?
Yeah, no, I absolutely use the 32K context all the time as a default. And some of that is because my experience has been that System Verilog, when I'm creating the prompts and giving syntax examples, System Verilog for whatever reason seems to be very expensive in terms of tokens relative to regular English language or even Python. So yeah, I always use a 32K window.
Okay. Next, Erik. So any thoughts on how this works on very, very mature test benches where only minor tweaks to monitors and checkers are done?
Yeah. So I will tell you that is probably one of the next frontiers that we have here. I had the good fortune of having a completely new IP that I was working on that I could build some of this collateral around. But if we're talking about maintenance of existing benches, I would give it the existing bench. I would ask it to make the change that you want, and then if it's unable to do that, I would give it the example and say, okay, this is the example of, when I ask for you to add in a new port or make some other connection, this is what I would have expected you to do. And then save that off. And maybe you didn't get the benefit on your particular instance or for your particular problem, but the next person that comes along is going to have a prompt available to them that they can leverage as a part of the work that they're doing, right? So there's a very snowball effect to this where each person can impact the quality of the results that the next person is going to get, and you got to kind of buy in as a team to be able to do that.
Okay, great, thank you. Next is from Jack. Do you perform any fine-tuning or retrieval augmentation generation using internal documents?
Fine. So use the word fine-tuning. We don't do any fine-tuning. Certainly documentation searches is right in the wheelhouse of what generative AI is going to be able to help you with, and kind of synthesizing results from different sources. So that's certainly all a good use of generative AI. Yeah.
So next is from EEB. So I'll apologize that I don't want to butcher the name. So thank you for tolerating that. Any resources you would recommend to advance our skills?
I will tell you that everything that I've presented today is available publicly, and not just from me, but these are things that I've learned from watching tutorials on LinkedIn, from watching YouTube, it's none of this stuff I think is much of a secret. You'll see it even beyond verification domains. You'll see the same kind of deconstruct the problem and use prompt engineering, and small prompts are better. You'll see this across the field. So all this stuff you can find publicly. Just look for YouTube. If you have a question about how to use generative AI for data interpretation, go watch some YouTube videos, and you're going to get some insights that you didn't have previously. I listen to a lot of podcasts on AI, and there's definitely a philosophy and a mindset that you got to have. And I didn't necessarily have that natively, and so I had to kind of have somebody else kind of explain it to me. But there's a wealth of resources publicly. And ChatGPT is a pretty good resource as well. If you want to ask it, how do I get better at some particular skill? It may actually guide you through the process. And if it doesn't, then there's plenty of other resources on LinkedIn or YouTube or Google or whatever.
Got it. Thank you. And again, just if we are at the hour and beyond 1 minute beyond the hour, so are you, Erik? Do you have time to join a little bit more or are we?
Let me see. I need to run.
Yeah. Okay. So what I'd like to suggest here is that we still have like 38 questions. So we will have we captured these questions. They're already they're in our in a webinar information. So what I'd like to do is that answer them in text, okay, and then provide that offline, and if that's okay with everyone. And maybe I think, Erik, maybe we could hold just a Q&A session, just no presentation, just a Q&A session that we can do in the future, just as a follow-up as well. Okay.
Sure.
But meanwhile, everyone, please join that Generative AI Slack channel. And what we'll try to do meanwhile is to put the outcome of this in the channel, so that for those who missed it. So please do that, because this is an asynchronous way and it's continuously available. Okay. And so, Erik, thank you very much. Thanks for your time, and thanks for the especially the sharing the knowledge in the Q&A. This is great. Thanks for everyone for joining, and we stay tuned for the next webinar next week. We're going to be sending an announcement for it shortly. Thank you.
Thank you, Mohammed.
Thank you.